Welcome to series of database management system video lectures. Today we'll be discussing about Unit 2, Topic 1, that is logical database design. The logical database design is nothing but a conceptual structure. How do we store the data? This is our database. Irrespective of the underlying structure of storage, we are going to define how our data will look like. How many number of fields that we are going to store. What type of data that we are going to store in the field or in the record, and any kind of constraints that are being applied to the data. So, logical database design completely focuses only on the conceptual model of the database, which accurately represents the data, its relationships, and it ensures efficient storage, accessing and retrieval to the data, and finally manipulation of the data. All these are the things should be done in a proper manner without bothering about the physical structure of the data. Yeah. So these are the steps for creating logical database design. We need to follow 1 to 10 steps in order to develop a logical database design. The first one is requirement analysis. So in this step, we will gather all the information about the model that we need to develop. So how do we gather the data? Either we need to interact with the organization and various stakeholders and what are the requirements of the organization. Accordingly, we need to model the data which is going to be stored in the database. Second is entity relationship modeling, which we have already discussed as part of the previous videos. What is entity relationship model? How these models are designed? What are the various tools that are available in the market? And the complex structure of the real modeling of the data can also be developed using extended ER modeling diagrams. Right? You can refer to the entity relationship modeling detail. And third one is normalization. So as we have collected the data, we will not be storing all the data in a single table, or if we have stored all the data into a single table, there will be a lot of redundancy of data, and then the functional dependencies will be more, and we need to reduce or decompose the large tables of data into smaller subtables. And normalization, as we have already discussed that, how do we perform normalization of data? In order to remove all the redundancy of data, and various functional dependencies are also going to be resolved as part of normalization. And fourth is data integrity and constraints. Now, how do we maintain this data integrity? What we have stored in the database, is that the same value that we are going to access? Now, we apply various constraints such as unique key constraint, not null constraint. Anyway, we will discuss these set of constraints as part of Unit 4. Check constraint. All these are the constraints that are going to be applied for making the data to be maintained in an integrity manner. And the next is data types and constraints. Now, when you are going to store the data, we need to, based upon the nature of field, we need to specify what type of data it can represent. For example, for the student entity, if I wanted to store ID number, this ID number, if it is a combination of only numerical digits, then we can mention the data type to be int. If the student ID number is a combination of alphanumeric, then we should mention it as varchar. So we need to be more specific for the declaration of the data items as well. And the constraints could be domain integrity constraints are applied here so that we will not violate the underlying data type size. Sixth is indexing. Now, In order to improve fast accessibility to the data, indexing is the important one, which reduces a lot of response time. It will not take more amount of time for searching for the required data. So we have various types of indexing mechanisms, that is single level indexing mechanism, two level. Okay. And next one is views and security. We store large amounts of data in various tables. But when the user has queried or requested for retrieving the data, which may be available from more than one table. So practically, it is not possible to bring all the data from various tables and then put it in some other new table. Instead, we just try to access the similar set of data items and then we present it to the user, but we will not store it. So views allows this kind of facility for accessing the data across various other tables, and security is offered by the database management system at various levels. We have three different types of users: database owner, database owner, database user, and then super user, that is administrator, database administrator. So in order to control the accessibility to the data, every type of user is given with a different access privileges. Accordingly, the data is going to be allowed to be accessible, and then we will be able to manipulate the data. That high level of security policies are being imposed upon the data. And next, transaction management. While dealing with this data items, each and every operation with respect to the data is done to read, to write, and to modify or update. So we will be implementing various transaction control language commands. They are commit, rollback. So these are the commands that are going to be used for accessing to the data in terms of the transaction. And ninth is performance tuning. Now, as we deal with huge amount of data, we need to access to the data that fastly and respond it to the user. So at any point of time, we should not compromise in terms of performance of the database. Whether it could be only one query that is being asked by the user or number of queries are being increased in order to offer scalable services, then that robust the database system should be designed. And finally, documentation and then maintenance. As part of performance tuning, we try to use query optimizer so that for each and every query, what is the amount of time that is being taken for processing that query, so that the response time can be reduced to a greater extent. Finally, we have documentation and then maintenance. Whatever the data which has been collected for any kind of modeling of the data, everything should be documented here properly so that at later stage, we will be able to access to it, and then this can be made as a reference to the next set of complex designing of the ER models or the database applications. The maintenance of the data should also be done at every monthly wise or daily wise, so that we will even look at the access rate of the data that fast. Using the indexing concept, we are going to reduce a lot of search time. Now, and who are the actors? So we have the main entities such as student, course, then enrollment. Okay. So these are the things around which the university operations are dealt with. So now we need to collect all the information about the students and we need to maintain that. We need to collect all the information about the courses. We need to find out the details and the schedules related to the courses in which students have enrolled. So this kind of information should be retrieved from the organization first. Secondly, the second step here is entity relationship modeling. So in the previous video, we have learned how to create an ER model for the student with the specified attributes, right? You can even use Draw.io software for designing this ER model. So identify the attributes. Student will have an ID, which is going to be given as a unique, right? So that's how it becomes a key attribute. And then student name, right? So all these are the attributes that you can define and what are the other entities that we have and the relationships or the associations that that are specified with respect to every entity. Refer to ER modeling video. Third, normalization. So the third step here is normalization. We need to, here for the enrollment into the courses. Okay. So you can even mention the attributes for the course, that is course ID, course name, okay. Enrollment, that is date, uh, time. So this is how we will develop the ER model. And the third one is normalization. Now, what is normalization? How this normalization have to be applied? Uh, what is the necessity to perform this normalization? We have huge amounts of data which is being collected in a single table. So that's how we need to break down all the dependencies from one table to the other table. You can refer to the normalization video. So we will apply the normalization techniques in order to remove the redundancy of data from the university database. And then we try to resolve all the functional dependencies, which can be single valued functional dependency, fully functionally dependency, partial functional dependency, and then joint dependency. So all these are going to be removed off. And fourth is data integrity constraints. Now, functional dependencies are by using student ID, you will be able to retrieve the name of your student. By using SID, you will be able to retrieve the information about the contact of the student. By the combination of SID as well as name, you will be able to retrieve any other attribute information. So you need to find out what are the possibilities of dependencies that are existing in this particular database. Fourth is data integrity constraints. Data integrity constraints. In order to make the database system to be consistent, we need to make sure that the data should be in integrity manner. So now what is the data that you are trying to store should be the same which has to be accessed or retrieved. Any manipulations to the data that are taken should be reflected in the same manner. So updations for read and write should be done immediately. That's how to maintain data integrity here. And this can also be done with the help of applying various constraints, that is primary key constraint, foreign key constraint, not null constraint, check constraint. These constraints helps us to make the database to be in consistent manner. So in this context of university, for a student ID, you can define it as primary key for the student table. For the student table. For the course table, define ID to be primary key. And for enrollments, you need to maintain combination of both the entities or both the tables. So make or define enrollment will have SID as well as course ID. A combination of these two are going to retrieve the information about the enrollment of the course. And fifth is data types and constraints. Now, data types. For the student, you have student ID, which should be an integer data type, right? We need to specify which attribute is capable enough to represent the nature of data. Accordingly, you need to specify the data type. Student name definitely be a combination of only alphabets. So we mention it as a string data type, right? And then contact number and date of birth should be specified as contact number can be mentioned as integer. Date of birth can be defined it as date data type, right? So we need to be very specific for each and every attribute according to the nature of value or the data which is being carried or stored. We need to specify the data type. And indexing. The next one is indexing. Now, why do we apply indexing? For improving fast access to the data, for a fast retrieval of data, we maintain a data structure that is index wherein you specify the records numbered from 1 to 10 can be accessible from so and so memory. So it maintains the pointers to various other underlying structures. Okay. Next, views and security. Now, I wanted to access to the data of a student from, I wanted to retrieve the information about the students who have enrolled for various courses. Now we need to access the data from student table as well as course table and the enrollment table. So we need to collect the data from multiple tables and present it to the user, right? So this is a view which is being displayed for the users for accessing the data of more than one table. 8, this transaction management, which we have already discussed. Now we need to apply various asset properties for this. Make sure that it is atomic in nature, consistent in nature, isolated, and then durability. By encompassing all these set of features, we will be able to perform or consider that transaction to be the correct one, or which can be taken into the steps. And performance tuning. So in performance tuning, we will try to find out how many queries that can be framed to retrieve the data from the database. Which query is going to perform the operations correctly with less access time. So query optimizer will try to evaluate all these queries and try to figure out which query is going to make the search engine to access to the data at a fast rate. So this helps us to have a better database application. Finally, we have documentation and maintenance. So in documentation, we will specify each and every operation that is being started from the beginning of the requirement analysis till the time where the implementation of the data is being done, and during the usage of this database application, what are the problems that have been encountered and what can be the bugs that can be fixed, and the solutions, the alternative solutions that are going to be offered. Everything is going to be documented so that it can be prepared as a manual for developing complex structures of the database. Right? So this will be the logical database design and the steps which have to be followed. Thank you.